Hello, welcome.
Hello.
Thank you so much for being here. It's a new era in Whitney's life. Maybe I don't quite have stuff together like I normally do. But the intro song didn't play. This is
Oh, I
supposed
heard
to
it.
be. Oh, you did really?
I heard it
I
on
didn't.
this side. I don't know if I heard it on the other. I wasn't listening on the other side.
Amazing. I couldn't hear it on my end.
Oh no.
And then it's so I was just like, oh crap. And then also, this is supposed to stream to YouTube and LinkedIn, and it's telling me the LinkedIn's not working,
It's
and I don't.
definitely working on YouTube because I'm watching it on. I can see it on YouTube.
Okay, that's and, and I think there's maybe some people here watching. If you are, welcome. This is Enlightening, but I recently got laid off from VMware, so it's an Enlightening just streaming only to my Wiggity Whitney YouTube channel when it usually goes out on VMware channels too. So if you found your way here, that means you worked hard for it, and I appreciate your time. So welcome to Enlightening. My name is Whitney Lee. I'm a CNCF ambassador, and I'm here with my friend Austin Parker. Tell us about yourself, Austin, please.
Hello, I am Austin Parker, director of open source at honeycomb.io and a longtime part of the OpenTelemetry project. I currently serve on the governance committee and help with sort of project steering and overall, directionality of things. And you might have also heard of me from the internet, where I'm the guy that did the Animal Crossing DevOps conference back during the pandemic.
Yeah, and that's how you and I met. I was a
It
speaker
is.
at Deserted Island DevOps, and I was extra and dressed up like my character, or I dressed my character in clothes I knew I had in real life. So it
It
was
was an amazing bit, to be honest.
we'll have to maybe we'll dig that up and put it on the internet. So I'm so glad to have you here now. It is such a gift that you're sharing your time and your expertise to teach us about OTel. Thank you so much.
No problem. Like I said, I'm super. I was saying before the stream went on, I was actually like in the middle of like writing some stuff about this. And over the past year or two, I worked with a buddy of mine and another member of OpenTelemetry, Ted Young, on a book called Learning OpenTelemetry, where we had to kind of sit down and really think about a lot of this stuff. So it's been at the top of my mind, like what is OTel and how does it work and what do you do with it for a bit now. So I'm excited to kind of come on and share it with all of y'all.
Before we get started writing stuff on the board, do you want to talk a little bit about like were you there in the beginning times of like the conception of
Yeah.
open telemetry? What problems were you solving or what? Yeah, tell me about that.
So let's maybe start with a little bit of a history lesson about
Yeah.
observability and telemetry. Several years ago, oh gosh, like 2012-ish, I want to say, there was this project called Open Tracing that started up. And the idea with Open Tracing was we needed a way for distributed tracing to be more popular. And the problem with distributed tracing is like you have to have it in multiple services.
Uh-huh.
And so you need kind of a single API. If you're if you're writing a library or a framework, you want to make sure that your traces work with someone else's library or service. And we wanted to give people kind of a single API to do that. And this was
Mhm.
adopted by projects like Jaeger, which is an open source, another CNCF project, open source trace visualizer and query engine. Projects like Zipkin, which came out of Twitter originally, I believe,
Oh.
and another trace viewer. And this was really super helpful for people because I think it really kind of started to turn people on, like, oh, tracing is this super useful way to visualize like requests as they move through a system.
Mhm.
um but there wasn't just open tracing, right? There was this other
Uh-huh.
project that Google was working on called Open Census. And
Okay.
the idea with Open Census was very similar, but we had different ways of going about it. So open tracing was just an API. Open census was more batteries included. It had an SDK. It also did
Okay.
metrics data. And the idea
Did
of
what data?
metrics data. So not just
Okay.
traces that also would give you, count of requests and like rate of requests and stuff like that. So there are these two separate projects that were both pointing in the same direction,
Uh-huh.
um, with this idea that telemetry data like traces and metrics and logs and the stuff that tells you what your system is doing shouldn't be some third party thing that you kind of add
Mm-hmm.
on, right? It shouldn't be an agent or something that someone else writes. It should be just kind of natively there. It should be just part of your software. You shouldn't have to
Mm-hmm.
necessarily go out and write it or wait for a vendor to kind of give you that telemetry data. It should be a built-in part of your system. And since we were both kind of going in that same direction, it made a lot of sense. We sat down and said, well, it is kind of silly that we're both working on these things that are very similar, but doing it in different ways. Why don't we join forces? And that is where OpenTelemetry came from.
Um, Fascinating. Because where does Prometheus's open metrics fit into this conversation?
OpenMetrics was something that kind of started around the same time as OpenTelemetry, and
Mm-hmm.
the idea with OpenMetrics was, Prometheus had its own exposition format, right? The way that metrics could be emitted from an application, but it wasn't a specification. It was just like, this is how Prometheus did it. And so
Okay.
OpenMetrics was an effort to codify that and write a spec about Prometheus metrics. And that's one of the things that we looked at as part of, when we were building OpenTelemetry, we worked really closely with the Prometheus maintainers and with the OpenMetrics people, the people creating that, to make sure that our stuff was compatible with their stuff. And so,
Okay.
like, and we're seeing that kind of, to jump ahead a little bit to
Uh-huh.
now, like Prometheus and OpenTelemetry are really, really closely, we work pretty closely together. And, starting Prometheus 3.0, like you'll just be able to send OpenTelemetry metrics to Prometheus natively. If you're already using Prometheus metrics, OpenTelemetry understands those. And our
Okay.
metric spec is actually kind of a superset of open metrics, right? So we wanted to make sure, one of the big kind of motivating factors for open telemetry was we wanted to reduce the amount of confusion, the
Mm-hmm.
amount of like options, I guess, in some ways. Like there should be, you don't need 20 different options for like how to write a metric or how to create a trace, right? Or even how to write a log. Like we do have 20 different options, but isn't it so much easier if there's just kind of like one well supported option that works everywhere and in every language? Especially if you're a developer working on like a third party framework or a library, right?
Yeah.
You don't want to have to go and necessarily like create your own thing or write a bunch of adapters
Uh-huh.
to other metrics frameworks or libraries. You don't want to necessarily have to deal with someone coming in and saying like, oh, I do logs in this one specific way. Like,
Uh-huh. It,
can you
it
change your stuff to work with my stuff? You
yeah.
would say no, right? But that
Yeah.
means that those other people, the people that consume your library, have to do extra work to make your logs fit into their thing.
Oh. I didn't really think about the middleware software, the third-party tools that are getting integrated, and how they kind of
Yeah,
owe it to all their users to be able to work in a format that works for the users.
yeah. I mean,
Um,
think about like Kubernetes is a great
yeah.
example here, right? Like if you're writing applications for Kubernetes, if you're writing a containerized app and you're running on Kubernetes, then you're gonna kind of comport to how Kubernetes does stuff because it makes it so
Uh-huh.
much easier because now all your tooling just kind of works together. And
Yeah.
and that's a lot of the idea behind OpenTelemetry is we want to provide that sort of shared layer of understanding of tooling, of APIs, of whatever, so that telemetry becomes built in, like so that this data is just there. It's part of your software. It's not something that you have to, go in and write yourself, or something that you
Mm-hmm.
have to expect a vendor is going to provide you with an agent for. You know,
Mm-hmm. I'm writing telemetry data should be a vendor agnostic
yeah, and that's
built
good for
in
you too as a user,
part of
right? Like
observability.
you don't get
Yeah.
locked in. You can
Mm-hmm.
do what works best for you.
Um, I want to talk a little bit more about OTel and Prometheus, and then I have questions, but I'm also open to you controlling the conversation. In my case, I don't know what I don't know, so if I
Oh
can
yeah.
like derail stuff. But anyway, you said Prometheus did you say Prometheus going to start exporting data in OTel format?
Um, I'm not a Prometheus maintainer, so
Uh
I would
huh.
need to double check. But my understanding is
Uh huh.
that, like, starting with like the next major release of Prometheus, they're gonna
Mhm.
start using the OTel SDKs and OTel metrics rather
Mhm.
than like open metrics. But I mean, but it's weird
Okay.
because like open metrics and OTel metrics work together. Like they're,
Mhm.
you know, there's a
Okay.
to
Promet.
make a broader point. Or
Uh huh.
actually, let's talk about let's nerd out for a second, if I could.
We weren't already.
We weren't already. No, let's nerd out about metrics real quick.
Okay.
I'm not a metrics expert,
Uh
but
huh.
one of the things that's really tricky about metrics is that depending on how big your software is or how big your company is, like that
Uh
actually
huh.
has a lot of impact. Like changes a lot of stuff around metrics. So a good
Mhm.
example is if you think of a company, if you think of something like Cloudflare.
Mhm.
There was a really good talk from an SRE there at Monitorama this summer about their kind of metrics architecture, and they're doing some like ridiculous terabytes of metrics every few days, you know because it's a global CDN, right? Like, and you
Yeah.
think about all the different events that are happening, every single connection, every time a
Mhm.
firewall rule gets tripped, every time a route gets mapped, whatever. Like that's a lot of stuff, and they need to keep track of that on this huge global scale, and they need to be able to really quickly kind of like dive in and investigate things. And then you think about like, okay, so let's pin that up here with like a Google or an Amazon or a Netflix, you know hugely global companies with like thousands and thousands and tens of thousands of services and da 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 da. And then you like go all the way back down to like a much smaller application, even if it's running on Kubernetes. Like there's just there's less things, right? Like you have
Yeah.
less users, you have less concurrent requests. The kinds of metrics that you actually care about, like the actual things you care about, are probably pretty similar in both cases. Like you care
Mhm.
about like count of requests, you care about latency, you care about error rate. But because of how much like the exponentially increased traffic that these bigger orgs are getting, the
Mhm.
way you represent that data has to change if you want to
Yeah.
have any hope of efficiently like querying it or alerting on it.
Uh huh.
And a lot of what OpenTelemetry has done with its metrics is it has built that use case out, right? It has said like, okay, what do we need to do? Like, what is the thing that the most efficient way of doing this, or the more efficient ways of doing this? Like, what is the thing that solves this for like the big company problems?
Uh huh.
And then we can work in kind of scaling it down, making it easier to use for the small ones.
Yeah. That
But a
makes sense.
lot a lot of OTel is kind of based on that idea. It's like, let's make the low level thing that works in this like super hyper advanced case, and then we'll figure out how to make it easy to use later.
Mhm.
um
Can I? Can I? So I understand. I think actually we should put a definition of OpenTelemetry on the
Oh,
board.
that would be a good thing to do. Yeah.
Yeah, and then but I think I want to go through and test my knowledge at you in terms of how the different signals are being collected and where they're being put, and
Okay.
in terms of how they're being queried. And then with that baseline knowledge, I'd like to kind of understand at what points is standardization happening, and what does that standardization look like?
Yeah.
Does that sound like an okay flow
That
moving
sounds like
forward?
great.
Okay.
Let's start with the definition then.
Okay. Open telemetry is.
So I'll read you the website definition.
Okay, I'm not going to write that one down yet until we agree.
Okay. The
Okay.
website definition is high quality, ubiquitous, and portable telemetry to enable effective observability.
High quality, ubiquitous
And
telemetry
portable
and portable. Okay. Telemetry
to enable effective observability.
to enable effective observability. That sounds like observability is making, OpenTelemetry is making the data instead of standardizing the data. Is it generating?
In the sense that, so this is why I think it's a good definition, but it's also a bad definition. Let's think about it another way.
Uh-huh.
You have a software, you have some sort of system, and in that system, events are occurring all the time.
Yeah.
OpenTelemetry says is a model almost of how to translate those events into useful data for observability.
That's good.
And I think that one thing that, you know, and like those events are like super interesting actually, right? Because there's so many. And if you think about it, there's like what's an event? It's literally anything.
Yeah.
When the assembly code, the microcode to like multiply two numbers together at a CPU, that's an event. That's a thing that happened.
Uh-huh.
But also like the result of the system is an event. So if I order something on Amazon and then a box shows up in my house a day later, that box showing up is an event and it's part of the system.
Yeah. And that, I do think that's worth something I've been learning too is like, okay, we have observability. When we think about observability, we could be thinking about like observing the behavior of a particular application and like instrumenting it at the application level. Or we could be thinking about, okay, how are two applications talking to each other and like at the network level.
Hmm.
And then we could be talking about like, how are our system components working? And we're thinking about it at an infrastructure level. And sometimes I think it would be nice when a particular conversation is happening to understand like if it's only true for one of those levels or if it's because they're all kind of different to me in terms of how they're solved.
I think, yeah, so there's a distinction, I would say, between like techniques and, well, let me rephrase this. So uh, those events, like I said, can come at those events are at sort of different levels and resolutions. So at the
Mm-hmm.
infrastructure layer, there are different types of events,
Mm-hmm.
and those events are related to things that happen in other layers. And
Mm-hmm.
there's different audiences to kind of like understand those events and interpret those events.
Yeah.
And sometimes you want to you want to have like a semantic structure to those events. You want to be able to say like, I want you to interpret this event in a certain way.
Uh-huh.
And so in OTel, we start out by saying, okay, you have these uncountable events happening in your system.
Uh-huh.
We are going to give you this model, this set of signals that you can kind of interpret those events as. And
Mm-hmm.
that gives you, and this gives you something that I'd like to call semantic telemetry.
Okay.
The idea with the semantic telemetry is that, you know, the shape of it means something. It means something to you, to a machine, to like a system that's interpreting
Mm-hmm.
that data for analysis purposes. It means something to you as like a human being trying to debug the system or understand what's going on. Um,
Uh-huh.
it means something to the system, to all sorts of different parts of it, right? To like a process, to a data processing pipeline, um, to how data is rendered in a graph, the kinds of visualizations or queries you could do on that data. Like that's why the semantics are important, because if,
Yeah.
if we just said like, oh well, here's a bunch of events and you have to inspect the event to see what it is,
Mm-hmm.
then it gets, then processing it is really slow. This goes back to what I was kind of talking about with the metric stuff a minute ago. Like an interesting
Mm-hmm.
takeaway is if you look at, again, things like Cloudflare or whatever, um, a lot of the events that they're actually processing are start out as just lines of text, right? They turn them into
Uh-huh.
metrics because
Yeah.
that's the only way to efficiently analyze those events, right? The
Uh-huh.
signal type matters. Um, so OTel gives us this model, this framework for taking events and turning them into semantic telemetry.
Uh-huh. Hi. We have a viewer. Hi, Attack. Oh,
Hello.
thanks for
Yay,
being here,
observability.
friends. Um, so so the amount of events in a system are unknowable. They could happen at all these different levels and really a mixture of the levels.
Yeah.
They also mean different things to different people.
Yep.
And then even within our signals, logs could be structured or unstructured. Metrics aren't there like gauges and histograms, like
Right.
different types of metrics? And then I don't know much about what tracing looks like yet, but so the amount of complexity in all of these variables that we're talking about is wild.
Yep.
And so the one thing we can standardize on, like OpenTelemetry, like anything we can standardize on, is going to help us make sense of
Absolutely.
this
Yeah.
world.
You're
Yeah.
100% right. So the way like I think some of the things that like OTel does differently here is that, our goal, to go back to what I said earlier, is we want to make useful data for observability. So what makes a signal useful? What makes a good event, or or I don't want to say good event. That's not the right word. But what makes like a good signal? So
Um, One quick question before we answer
yes.
what makes telemetry data useful, which is a great question. Um, you said one thing OpenTelemetry does differently. And
Hmm.
my question is differently than what?
Than previous open source observability frameworks, schemes. Like we can sidebar this for a second if you'd like.
Oh, yeah, yeah, at least with our voices.
Yeah. So
Be- because
I
yeah, you tell me. Sorry.
I think, so very broadly, there's been, over the past like 10-20 years, we've seen a lot of different people come, like different ideas about like this is how you do observability. And
Mm-hmm.
hmm, I think like Prometheus is an interesting call out here, because by and large, like the Prometheus way is like, well, you can just make everything like all you really need are these metrics, right? Like these metrics give you most of the information you need, and then you still have your logs and you go look at your logs. There are other sort of more like log driven things where it's like, oh, well, you have logs anyway, so we're going to make really efficient ways to like encode those logs and store those logs. or we're going to give you this structured logging format, and you put everything into the same structure, and then you plug it into this thing over here, and that's your observability. Or you look at commercial products like your Datadogs or whatever, where it's like, look, just install this agent and it gives you all these different things. But now you're kind of locked into this commercial, this commercial ecosystem.
Uh-huh.
What I think is different about OTel is that it's approaching this from a different perspective.
Mm-hmm.
Where like a lot of incumbent ideas and a lot of ideas about how to do observability are very focused on, like, okay, we're gonna do metrics, or we're gonna
Yeah.
do logs, or we're gonna do
That's
tracing.
that's what I'm hearing from you too. What the definition you read off of the website with ubiquitous
Yeah,
is, I think, maybe coming into making more sense to me now. So it because it's focused on the whole ecosystem, not one particular angle.
yeah.
Eh,
And it's not focused on, like, it's focused on the relationships between data. So, have you heard
mm,
of people, maybe you've heard about this idea of there being three pillars to observability?
yes.
We disagree.
Who's we? Oh, open
Open
telemetry.
telemetry. So
Okay.
the open telemetry model is there are no pillars. There is a
Ah.
single interconnected braid of data. There's a stream, and there's connections between the data in that stream. Um, and that's what we're giving you. We're giving you that pipeline of data that is all highly correlated, highly interconnected, and that actually that's a super radical thing, actually. Like, that's not how observability works in people's heads. And it's one of the
Yeah.
things that's like really challenging to, like, maybe a reason we don't talk about it that much, or we don't put that like up front, is because we don't want to scare people off, but also because, like, it's so different than than how we kind of than most people think about the problem. you
Uh-huh.
know it's hard to actually like put your head around it. Like, it's
Yeah. So I think
yeah,
maybe that answers the question on the board, is like what makes it useful is that it's highly correlated with the other
yes,
data in the system.
exactly.
Um,
um and that is like the thing that OpenTelemetry really gives you, is this ubiquitous I can't
ubiquitous. I feel
ubiquitous
it. Yeah.
ubiquitous the position of the Q in that word always messes me up. It's the ubiquitous nature of the telemetry, and the fact that it is correlated together gives is how we achieve that goal.
The OUS, ubiquitous standardization.
Yeah,
Um, the word I can't say is anecdote or antidote or anecdote. I get
anecdote,
like anecdote. Yeah,
anecdote.
where to
Yeah.
put the C.
Yeah. Well,
uh,
I'll say anecdote for you, and you can say ubiquitous for me.
Perfect. So the ubiquitous standardization, I can at least understand in concept.
Hmm.
Um, how to achieve high correlation between, like, make the three pillars into a braid,
Yeah.
that I can't infer.
So, perfect segue into, you actually asked earlier, kind of, how does OpenTelemetry work, or like,
Uh-huh.
but so let's talk about how it actually does this.
Okay.
Um, at the lowest level, OpenTelemetry is software, right? Like, it's a API. Um,
That's even already kind of blowing my mind because standardizations are not software.
that's
They're
yeah.
yeah.
It's both a standard, a specification, and software. So it's
Okay.
it, it's it's a lot of things.
a standard. That's another thing that's maybe hard. And I did know there's a collector element and there's like a glossary or element.
Mm-hmm.
Standard specification. And what's the third thing?
Software.
Is the software the collector or is there something else?
So it's the collector. It's an API and it's SDKs.
Okay.
Technically, those APIs and SDKs are implementations of the spec, like reference implementations.
Okay.
Um,
Okay.
there's some nuance in there that's like not super important right now for this discussion.
Okay. And this is definitely where my mental model is lacking. So if I have a Java application.
Yep.
And so then I can use an OpenTelemetry API
Mm-hmm.
to emit telemetry data
Mm-hmm.
from this is a OTel API.
Yep.
To emit telemetry data from my Java application. And then where the SDK comes in to help get it into a collector? What does the SDK do from here?
So a really important part of the idea with OTel is this idea of composition between API and SDK. Remember earlier when we were talking about middleware and libraries and frameworks?
Uh-huh.
The idea is that if you're a library author, you should be able to depend on the OTel API and write telemetry for your library against just that API and not have to ship an SDK with it. And then, so let's take your Java app, for example. You're writing, and you see like, oh, I have some shared functionality or a database client or something. I'm going to pull it in. If that library is using OpenTelemetry and you're using OpenTelemetry in your code for your business logic, then all that telemetry now just works together seamlessly. So in your service, you bring in the SDK. The SDK listens to the API, turns the signals that you're creating the API into actual telemetry data, and then does some processing on them, and then exports them to a collector or some other destination.
So when you say in your service SDK, you like if you're bringing in the database, the data.
Like, yeah, you're bringing in a database client library,
Yeah.
but then let's say you're using like Spring framework or something, right? You have like when you initialize your service, you import the OpenTelemetry SDK as well, and all of these libraries and dependencies they're using, they've imported the API, you've imported the API and SDK. That SDK that you've imported will also pull the telemetry that's being created by those API calls that you didn't write in your dependencies.
So
Another way to think about this is, in Java at least, you can just there's a tool that we offer called automatic instrumentation for Java, where you tell when you start your jar, you say agent path hotel.jar, and it kind of does a lot of this stuff for you. It imports the SDK for you and configures it and does all that stuff.
So you have lower level things that just use API to emit telemetry data, and then higher level abstractions, whatever it is, that use the SDK that may automatically or not or manually, but like receive that telemetry data and be able to correlate it and do stuff with it.
Yeah. The idea is that if the API evolves very slowly, so that if I'm like writing a framework or middleware or library or whatever, I can import the API and then it's not going to break, right? Like I'm not going to have to deal with Another way to think about this is like log4j, right? Or various logging libraries in the past where it's like, oh, there's some, it's like, oh no, my logging library has a problem. I have to go through and update my logging library everywhere and all these third-party dependencies. If you're just using the OTel API, then there's really no moving parts there. It's just the API. And if I have a service and I import a dependency that depends on the OTel API, but I don't use OTel,
Mm-hmm.
then it's just a no op. Like nothing happens, you know?
Okay.
Um, but if I came in later and I said, oh, I'm going to add in OTel now I get all this extra telemetry from my other dependencies. Oh, we have a visitor.
Oh, I heard your friend earlier at some point. I heard a meow. Look at
Oh,
that. Hello,
she's
welcome.
she's here. She's
What's her
here to
name?
learn about it. This is Luna.
Hi, Luna.
Luna
I
is a
aw. I keep my
she loves
angel locked
OpenTelemetry.
out. She's like, I have no thumbs, but I have things to say.
Yep.
The Open Telemetry API, it's one API or is it like specific language
It's
specific
one.
or
It has an implementation in each language, but it's
okay.
basically it has the same concepts from language to language.
Mm-hmm.
Although there's like affordances for. We try to make it feel. Oh gosh, what's the word?
Gana Tech says hello to Luna. You can let her know.
Oh, the internet says hi, Luna. Oh gosh, I can't remember the word is escaping me, but we basically try to make sure that the API feels like consistent with the language. So like if you're in Python,
Yeah,
it doesn't necessarily feel like writing Java in Python. It's supposed to feel like writing Python in Python.
right on.
Um, that's the point, at least.
And so, what other points should we make about the API specifically, or what is the OTel API?
So the API is how you as a developer translate you you are translating events that happen in your system in your code into a signal. So that's how you say this like this is a metric or this is a span or this is whatever, right? Like the API is how you tell OTel like okay, this is what this is. So I might want to have a counter of some sort, or
Uh huh.
if I have some part of my code and I'm like, okay, I need to count how many times this gets executed over however long. Well, I'm tracking numeric events over time, so that's a metric. So I'm going to create a um, you know dependent, maybe I need to create a monotonic counter, maybe I need to create a non-monotonic counter. So basically, does
Mm,
this only go up? Can this go up and or up or down? Based on whatever your criteria are, like whatever you need to know, like you use
mm-hmm.
the API to create that instrument or that signal,
Mm-hmm.
and then you know da 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 da, right? You're done. The
Mm-hmm.
SDK
Mm-hmm.
um, listens for things coming from the API and actually does a few other cool things that is where we get into that correlation that we were talking about earlier.
Mm-hmm.
The most important thing that the SDK does is that it helps define the context for your signals. So context is a super overloaded word, but it's a really
Mm-hmm.
important one in OpenTelemetry. And when we talk about context, what we mean is what else was happening at the same time that this was.
Mm,
And we also mean that like from a sort of higher level perspective of like, okay, what do all these things like, is there a single transaction or a single request that all of this stuff belongs to?
mm-hmm.
So if you think about um, an e-commerce website, when I go and I want to add something to my cart, I click a button on the web page, and that kicks off who knows how much stuff in the background, right?
Mm-hmm.
We
Isn't
can.
isn't
Oh, go on.
Oh, what you're saying sounds like tracing generally, and not
Yeah,
necessarily specific to the situation. Okay.
but let me bear with me.
Okay.
Bear with me for a moment.
Yeah.
So so I click the button and that triggers all this stuff on the back end, right? And
Uh-huh.
normally in the way that like the traditional observability way to think about this is like, oh, I just described a trace, right? I described all the like what is
Yeah.
all the work that's happening in this system that correlates to this operation or to a single user request. OpenTelemetry treats that as a generic context, right? It says, okay, well, maybe I don't necessarily like whenever I am making a transaction through my system, like that is a generic context that I can attach other things to. So if I have a log message, for example, then I can attach that log message to that context. If I have a metric, I can attach that metric to that context.
Mm. Okay.
So what this allows us to do is we can emit data that lets you ask questions like, okay, for this specific request, like show me everything else that was happening. Show me all the metrics that were happening then. Show me all the logs that were happening then, right?
Is this something that has to be done manually?
It doesn't have to be done, well, which part? The analysis part or the connecting the data together part?
Uh, the analysis part. I guess the API part is the analysis part. What's the analysis part?
The analysis part comes way later once you've actually put this data somewhere.
Ah, yeah. No, I haven't thought about that part yet. I'm here. I'm
Okay.
living in the moment here with
So
you.
so all of that correlation stuff just
Uh-huh.
happens automatically.
Oh, nice.
Like that's why the OTel SDK exists, so that we can attach that context to all the signals that are coming out of it.
That's very valuable.
Yeah. And also, in addition to that, because there are a lot of things that happen that aren't necessarily like there are things that happen that aren't necessarily measured as part of a single request, right? Like how much memory am I using right now doesn't necessarily map to
Ah.
a specific transaction in my system. It's just
Mm-hmm.
time. So that's when we get into this other type of context we have, which is around metadata and resources
Mm-hmm.
and attributes. And that's things like what pod is this running on? What load balancer did it hit? What feature flags are a part of, are running right now? There's so many different things that can go into this kind of metadata, and OpenTelemetry provides a standard for that as well that we call semantic conventions.
Which load balancer? And we're back to the word semantic.
Yeah, it keeps coming up.
And semantic conventions are they they're just a separate thing, like in terms of all the different specifications. One of the
they're
specifications
they're a
is a
part of the
semantic one.
specification, but they're like a separate section of it.
Okay,
So the
but
idea, oh,
like is it part of the SDK?
it's
It's just a whole thing.
kind of like
Okay.
they're defined as a part of, actually technically would they be part of the API? I'd have to actually double check my thought process there, but
Okay.
um they work. I think they would be actually part of the SDK because they're modifying the emitted telemetry, but they're defined. So they're
It's
kind of they're a little set. Let's talk about what they are, and then we can figure out where they belong, where they sit.
okay.
What they are is standardized metadata about things that happen. So if you think
Ah,
about a HTTP request, there's there's it doesn't matter like what language you're working in. It doesn't matter what HTTP server or client you're using. It doesn't matter if you're doing an HTTP request from a phone or from a Mac or a PC or whatever. Like there's things that you kind of just care about, right? Like you care about the URL path, you care about the HTTP, request type, you care about the response status code. Semantic conventions are effectively a very big list, a very big
mm-hmm.
mapping of like these are the things that these are the things you care about for this type of thing, and here's what it's called, and here's all the permissible values for it.
Mm-hmm.
So an HTTP server in Java will have the same convention, or have the same metadata on every piece of telemetry it emits as a HTTP server in Python or in Go or in Rust or in Erlang or in whatever. And that's the advantage of semantic conventions, is they apply this nice level of standardization so that telemetry, understanding telemetry for you as a human being can become kind of like a transferable skill, but also so that people can build other things on top of it, right? Like machine
Yeah.
analysis, like AI models, whatever. Like now there's this, OTel kind of gives you this like, oh, it all kind of looks this way and it all kind of acts this way. So I could build a tool that actually does something with all this data, since I know how it's going to come to me and what it's going to be shaped like and what kind of values are in there.
Yeah. Amazing. This is so helpful. And hello, Martin. Hello, Fields Novel. Good to see you, friend. You found me here, streaming off the VMware channels. Um, this is so, so helpful for my mental model. And I'm wondering if I can talk about what I know and then kind of you could help me understand how this fits in.
Sure.
And in the short term, we'll talk about it as an application level, but I'm also curious about how this affects like uh, data that's collected at an infrastructure level, since
Hmm.
we're talking about instrumenting applications specifically. But let me think. So, so we have an application, just like whatever, a Java application, and what I understood is I know that it is instrumented with OTel, and then Jaeger takes it and stores traces somewhere and visualizes traces, but it's getting stored somewhere,
Yeah.
right? And then Java also, what I thought was it was probably have some sort of exporter to store um, its metrics somewhere that are getting scraped then by Prometheus, which itself is storing. Well, depending on the implementation, it could be Thanos or whatever, but
Hmm.
um, but Prometheus itself metrics, but it's in its own spot. And like what I'm learning is like you use Jaeger to query this. You use whatever Prometheus tool, PromQL, to
Yeah.
query this. Uh, Jaeger has a UI to query this, and then and then logs. Like I guess I don't. But even then, I talked about like Loki or whatever. Like there's its own
Sure. Like there's logging databases, Elasticsearch,
right,
um,
and
OpenSearch.
then maybe it's OpenTelemetry, get it there. Maybe it's, let's just say it's a Fluent D, like daemon set. Why not? And but the logs can be, and so because they're all like being going to different destinations,
Hmm.
even if they're correlated with each other, I kind of don't quite understand what happens from here.
So let's there's one part to this that's like a little missing, and that's like the collector part. Uh,
Okay.
So the collector, we can actually kind of elide a lot of it because but it's the thing. So your Java app would send stuff to the collector. The collector would process it, transform it, do redaction, whatever, and then forward it on to those destinations. So that's
Okay. Okay. I don't. So it goes collector.
yeah, app collector, wherever.
But it's still three different databases for three different types of
Well,
signals.
it can be.
Okay.
So this is OpenTelemetry as a project has decided that we are not that the line that we kind of stop at is that like right after that collector
Yeah.
because there's a lot of like very good there's a lot of reasons for that, and a few of them are, you know, if OpenTelemetry came out and said like, "Oh, we think you should put all this data into this type of database," then we could actually probably do a lot of optimizations around that. But our goal is to make, a big part of our goal is we want all this stuff to be like truly portable and vendor agnostic.
Mm-hmm.
So we can't really like start making optimizations that prefer one type of data store over another.
Yeah.
What we are doing as a project is we are giving the community options, is how I
Mm-hmm.
see it, right? We're giving you this stream of data and you can send it to the collector and then you can
Mm-hmm.
do whatever you want with it. I have seen, there are some companies out there that treat all that data the same, that treat, that don't, that are using like column based data stores that don't necessarily put it into separate databases so you can query it all with the same language, same query dialect, whatever.
Uh-huh.
I have seen people that like throw it all into Kafka and do stuff there. Um,
Uh-huh.
as a project, like we're not going to tell you what to do with it. We want to give the community and we want to give people that are building that we want to give them options, right? We have given you this braid of data. If you want to take it and then break it apart and put it into three pillars, you can. That's a
Okay.
valid use case for open
Is it?
telemetry.
Okay.
It's a valid use case. Like we don't stop you from doing it.
Uh-huh.
But what we want to encourage people to do is we want to encourage like both vendors and sort of the open source community to look at what open telemetry can give you and start to think about like what could I build on top of this, right? Like
Yeah.
how can I leverage these connections? Because there are ways that even if you have all this stuff in three different databases, like you can
Uh-huh.
still use those correlation features, right? Like you can still say like, well, all of these attributes, I know what these attributes are. They're going to be consistent between metrics, traces, and logs. So I could build like links between stuff. That content, those context IDs are going to be in the same place. Like you can build sort of walkways almost like between,
Mm-hmm.
these little connections based on this fixed context. But there's so much more that you could do with it. Um, and I don't. It's something that the industry really hasn't caught up to yet, and I think that's fine. Like it's still, OTel's been around for 5 years, and we've really, it's been kind of it's hit its stride really in the past like 2 or 3 years.
Uh-huh.
To start getting a ton of adoption. So I'm not surprised that we haven't seen like a ton of super innovative things yet,
Uh-huh.
but we are starting to see them. And I think that there's a lot of, you know, a really simple, I'll just give you a simple example, or not a
Uh-huh.
simple example. Sorry, try not to use that word. A straightforward example.
Okay.
If you have metrics, logs, if you have all this data and it's one braid of data,
Uh-huh.
you could feed that into a system that looks at all of it and like understands how like the gaps, like it understands like this data, this metric is shadowing these things that I have logs for or I have traces for. So I'm going to actually prioritize where data is stored or if it's even saved at all based on like, do I have, data that kind of covers that time period that shows me something interesting.
Mm-hmm.
So right now, a lot of people wind up spending a lot of money to save the same thing twice, right? They'll take their logs and they'll put them into an observability tool, but they'll also put them into a security tool.
Uh-huh.
Using OpenTelemetry and using this sort of correlation layer, you could build really intelligent adaptive and dynamic sampling tools and storage tools that are able to like route this data to the appropriate place
So
or
you,
decide what
like,
gets exported and what doesn't, based on those correlations.
so you could, I don't know, try to define what's normal for your system and only send it to long-term storage if it goes outside of your normal range,
Right.
because that's something you might want to look at later. And maybe at that if anything's abnormal, you save everything, all the context from that,
Yes.
and that's what goes to long-term storage. But then anything else is, if it's normal, is only saved for 48 hours or whatever.
Exactly, right? Or it's saved like closer to the source,
Mm-hmm.
Um or it changes like alerting, or even because OTel can kind of talk to other OTel things, like you could even have this feedback loop of like something looks abnormal over here, but I need more of this other signal. I need more
Mm-hmm.
like traces, or I
Turn
want more
turn up the
data.
volume over
So turn up
here.
the volume back here on my
Okay.
services automatically.
Uh-huh.
And that's the sort of stuff that can be built on top of the foundation that OTel is providing you.
Okay.
Um, Now, does that all exist yet? Not entirely. Will it exist? I'm confident that it will.
Yeah. I'm going to erase this, but I'll when I said like understanding where in the system OTel comes into play, it's coming into play with instrumenting the application,
Hmm.
and then it's coming to play into play with the collector, which we haven't really talked about yet.
Yep.
And then whatever happens here is just like anything. Like
That
we
anything
can't do it
goes.
all. Ubiquitous to a to a limit.
We we don't want to do it all. I think there's
Yeah.
a we want to we really want to provide, like I said, this very comprehensive and thorough sort of foundation for the observability community, for vendors, for other people to come in and build on top of. Because, you know, like I think Prometheus is actually another good example here, right? Where it's like
Mm-hmm.
other people have come in and made things like Thanos and Cortex, like
Mm-hmm.
it's I think the advantage of like working in an open source system and working in something like the CNCF is that like we're not just trying to say like, oh, you just use this thing forever and ever and ever. We're trying to build a real ecosystem around OpenTelemetry so that not only are we making people's lives better, and we're making it easier to kind of do all this stuff, um, but we're giving other people opportunities to sort of push the state of the art in
I,
observability.
yeah, and it sounds like at this young stage, there's a lot of room for innovation. It
Definitely.
sounds like it's a really exciting place to be. Which
I think so.
I'm asking someone or saying it, someone who's slightly biased, maybe.
Yeah, I am just marginally biased, but
uh, a comprehensive and thorough foundation. I'm writing kind of too small, but whatever.
yeah.
You can zoom in if needed. So, so did we say, okay, I want to repeat to you what I think I understand from API and SDK and make sure we have that covered. But then I also have a question that I'll
Okay.
save to the end. So the OTel API is more low level. There's an implementation in each language,
Hmm.
but it's how a developer can add code level events and
Yeah.
make them into a telemetry signal. Um, so and is it manual? If it's a homegrown app, you're doing all
I
that
mean,
manually, or is there any kind of intelligence to it?
so there are higher level things that you can kind of plug in. It just
Okay.
depends on the language. So like a good example is in Java, there is
Mm-hmm.
an extension method called with span,
Mm-hmm.
and you decorate a function call. You just do at with span in front of the function call, and it instruments
It
that
does the
function
span
for
for
you,
you.
right?
Okay, cool.
It varies from language to language. That's what I when I was talking. The API itself is deliberately low level, but we are building like higher level affordances on it to try to make some of this stuff easier.
Mm-hmm.
Um, but
Cool.
there's you can write the code instrumentation yourself. You can use automatic instrumentation through agents and libraries. There's a couple of things now that use tools like eBPF to kind of do
Oh,
instrumentation outside the application, like more black box style.
fun.
Um, there's a lot of different things that exist in OTel, but if you're just saying I need a metric, I need a trace or whatever or some,
And
and then you're using the
for
API.
conversation purposes, yeah, it's nice to think of it that way.
Yeah.
But it's good to know it's out there too. And then we have the OTel SDK, so that listens to signals from the OTel API, and then it can do cool things with those signals.
Yep.
But what you focused on is it defines the context for the signals. So what else is happening at the same time? Is
Hmm.
this a part of a larger transaction? Like how are those signals relating to each other? And that's added automatically, and also it adds this semantic specifications. It adds to standardized metadata about things that happen too.
Yeah.
Uh, so that is great. And then my question is, that, first of all, is there anything we want to add there in terms of OTel API and
I
SDK?
I think that's that's the basics. There's a lot of
Okay.
there is more than we have talked about, like and I do want to shout out OpenTelemetry.io is
Okay.
our website. We have docs on there and the entire specification is on there, and so if you really want to nerd out about this stuff, you can go through and read that and it will exhaustively explain everything. But yeah, I think at the high level that's a good understanding.
Okay. And now my question is, what about system level uh, observe events that you want to observe that aren't application level, like we're talking about here?
Um, so there's a couple ways that you can do that. So today, what people do is they use the collector because the collector can collect both
Mm-hmm.
open telemetry data, but it can also translate from like from existing system level data or whatever into open telemetry data. So
Mm-hmm.
if you want to take your journal D logs and turn them into something else, you can do that in the collector. If you
Okay.
have a Windows system and you want to take events out of the Windows event log and you want to turn them into OTel metrics, like you
Okay.
could do that in the collector.
Got it.
Um, in the future,
Mm-hmm.
we hope that system level metrics will also be exposed as like native in OpenTelemetry native formats. But until then, we have the collector to kind of bridge this together.
Cool. So I guess that segues us nicely into talking about the collector.
Yeah,
If that feels right to you, how are we, in terms of your vision for what we were going to talk about,
I think
how are we?
we're good. Like I mean, we're it's a lot written down, isn't it?
Yeah, and I knew the collector was coming, so I've been saving some space.
Yeah.
So let's start with what the collector is.
Um, yeah. So when I think about this, I like to kind of describe OTel as like there's sort of two parts to it. There's the instrumentation and there's pipelines.
Mm-hmm.
And the collector is really the pipeline part of OTel. Just in a practical sense,
Oops.
you know, you need, when you take telemetry data, you need ways to process it, to transform it, to centralize it, to compress it, to dedupe it, to remove PII, whatever. There's a ton of different things that are challenging to do at a code level, right? Like you could do a lot
Uh-huh.
of this stuff just in, in your application,
Uh-huh.
but but practically the people that are writing the code and writing the instrumentation and the people that are like collecting the data are different teams. Like
Mm-hmm.
a developer is going to go through and write the instrumentation, but like an SRE or an IT an ops person is going to be managing all this and centralizing all this into dashboards. So the idea is, the collector lets you kind of handle all the other stuff from about where the data goes, how it gets processed, how it gets transformed from like one thing into another, because maybe some people, a really good example of this, maybe you have a service that only emits logs, but you really want to store that as metrics. You can do that in the collector. It's a Swiss Army knife for telemetry.
A data pipeline Swiss Army knife.
Yeah.
And then helps you do things with the data that you collect, right?
Yeah, it makes the data more valuable. Um, is kind of one way to think about it. Like a common problem I think in sort of observability is when you think about how much data, how many events your system generates, there's a really big kind of gulf between like the utility of that data and how much of it you have.
Uh-huh.
Because if you
Yeah.
think, let's think about just in any software system. If you want to be reductive, there's systems that exist in one of three states. Either everything is working perfectly fine, there's
Uh-huh.
no errors, no
Uh-huh.
traffic, no nothing, or everything is broken, in which case everything's terrible, or there's the middle state, which is where most things are most of the time, which is things might be working, things might not be working. We don't have a way to know. Um, but we know that, like, especially cloud native systems are kind of always in this consistent state of like half working, half not. Like,
Uh-huh.
and it's not that they're not working, it's not that they're not functional. It's just that like the way we design the systems, like there's too many things that could happen. There's unknown
Well,
unknowns, right?
yeah. And failure is part of the model. Like it's the pods are yeah,
Yeah,
restarted
like
rather than
we
fixed. Yeah.
restart it rather than fail. We have
Mm-hmm.
exponential back off. We have
Mm-hmm.
and it's the interaction between all of these various like states, these quasi working states, the emergent properties of the system that kind of come out from these, that like that's why we want observability, so that we can understand when things are going wrong. But it's also like super super hard because it's an emergent property. You don't know what to collect
Mm-hmm.
before you've seen the incident or whatever, because if you did, then you wouldn't have this problem to begin with, right? Like,
Yeah.
so a really big question in observability is like, well, how do you manage that? Because if you one way to do it is to say like, okay, well, we'll save everything,
Uh-huh.
right? But that's
Expensive.
very expensive.
Yeah.
Not just and actually something that a lot of people, I think people tend to think that's like, oh, it's the storage that's expensive, but actually it's not. Like, storage is cheap. If you just want to keep everything forever, like that's
Mm-hmm.
actually relatively inexpensive,
Oh, interesting.
um depending on how you store it. But it's
Yeah.
expensive it is to search through that data,
Oh.
right? Because the
Uh-huh.
more data I have, the longer it takes to find stuff. So there's this triangle almost of like, the joke about like fast, cheap, good, pick two.
Yeah.
So I think in terms of observability, I think there's this like triangle of this trade-off triangle where you
Yeah,
have,
I've been thinking during my job search I've been thinking of that triad.
yeah.
Anyway, go on. Sorry.
Well, no, but it's
Um,
like, yeah, it's like you have availability
uh-huh.
of data, you have um availability, consistency. No, not consistency. I can't remember my own metaphor now, which is terrible. But you're basically trading off. It's like you're effectively trading off between how much data, the amount of data I have access to, how quickly
Uh-huh.
can I query that data,
Uh-huh.
and like what's the resolution of that data? Like how detailed is it?
Uh-huh.
And every decision you make is sort of like pushing you towards one of these extremes. Like if you want to prioritize how detailed your data is,
Uh-huh.
then you either are
Is is cost
integrity,
one of
yeah,
these?
integrity. Someone can attack in
Oh,
the YouTube.
thank you,
Integrity was the
Ganatech.
word I was looking for.
Oh,
Integrity is
how
like a
detailed is?
detail, yeah.
Okay.
But
Access and availability seem like the same to me.
speed and availability. I think maybe integrity is a better way to. Either way, let me describe it narratively, and it makes more sense.
Okay. Cool.
If I want to have like 100% resolution, if I want to have like super high detailed data, I can
Uh-huh.
do that, but it's at the cost of either how quickly can I access that data,
Mm-hmm.
by virtue of like, okay, I can write all of this stuff out as JSON blobs to an S3 bucket and then use, Athena or something to query it. But that query is super slow because it has to go through, like, I can't efficiently index all that data. It has to like do a manual search through terabytes of JSON documents.
Mm-hmm.
Um, so if I want to, so okay, well, if I want to make it fast, well, then I need to do sampling, or I need to do something where I'm like indexing the data and only saving like sparse representations of it somewhere. But that now has like availability issues where I'm gonna, preemptively say like, okay, well, I need to get rid of stuff that is not interesting, so I'm gonna drop it. I'm
Mm-hmm.
gonna sample out data, but then, oh, maybe it turns out that was important data.
Mm-hmm.
So to fix that, now I have to go back. I have to prioritize integrity again. And you see how you can't draw the entire triangle. You're always moving the puck between these different extremes
Uh-huh.
to try to get something that works for you. Um,
And so the collector, you quickly rattled off some actions that it might do, even though it's infinite. But those examples help my mental model. So you said like you could use it to obfuscate
you can
PII.
obfuscate things. Yep.
You could dedupe your data. What else can you do really quickly with it? What are some things?
You can
Filter.
transform data from one type to another.
Okay.
You can um, do sampling with it, so you can remove and filter data. You can drop things.
Okay. Okay,
You
that's
can
cool. That helps. And
translate between formats, so you can go from, you know some existing, so you can take like an nginx access log, and you can put it into the collector and translate it into OTLP, or to OpenTelemetry protocol, right?
uh-huh.
So I think the relationship between the collector and that sort of balance is the collector is the tool that helps you find that balance for yourself. Because
Okay.
it's capable of doing operations on your telemetry that move it one direction or another on that. If you want to prioritize quick, data integrity, or you know quick access, then it helps you do things like, for example, a quick way to access a bunch of, really strong example here is data deduplication. So if I
Uh-huh.
have a log file, I could have a collector processor that goes through and translate and then says like, okay, I'm every time I see this message, I'm gonna emit one message that has how many times it's repeated in it, right?
Uh-huh.
So instead of emitting 20 things, I emit one thing, and that's a
Uh-huh.
way to um, make that integrity, speed, access trade-off, right? And the
Uh-huh.
collector helps you with that. The collector can do that for you.
And so there are a couple things I think I know about the collector, but I want to verify and understand how it fits in.
Hmm.
And one is the collector is, I thought, like a reference implementation. So is it like, is like the logic and what it does the part? That's what I maybe don't understand.
So the collector is actually not part of the spec.
Okay.
So the collector, it is, it maybe should be. Um, the collector is kind of a separate piece. It's not
Uh-huh.
something that we specify. Someone could re-implement it, for example, if they wanted to rewrite it in Rust, which is very
Uh-huh.
popular these days. Someone could, but it would be like there's no spec that says this is what a collector is right now, at least. Maybe in the future there will be. I don't know. Um,
So so the hotel collector, it um it's one thing, but I have the ability to add my own custom logic as toward the processing part.
yes. So
Okay.
you can either like write your own code, you can write your own modules for it, your
Uh-huh.
own processors or receivers or whatever in Go, and then add them in. Or we have a transform like we have a processor called the transform processor that lets you kind of write translate, you write little rules, it's a little rules engine that you can write statements in to do things like obfuscate a value or drop a value out of something you would like to keep. The collector does a lot of stuff.
Yeah, it does so much it's a little overwhelming.
It's
So you write your own processors.
extremely.
Is it I mean, I imagine a lot of people need to do the same type of thing.
Hmm.
Where are there just like you could use an open source version of a collector that already does a really that handles a popular use case? Is that normal, or are people always
um
building their own?
there's I give you a strong sorta. We do a lot of one thing that we're trying to get better about as a project is sort of getting recipes for stuff like
Mm-hmm.
that, like collector cookbooks,
Yeah.
of hey, this is how you do this thing in the collector. Some of that exists, but it's a little just sort of scattered around GitHub right now, or in people's
Okay.
blog posts. But
Okay. So it's common to write your own.
it's
There's not a lot of
there's
cookbook
not like
stuff.
right now we sort of lack a just drop in whatever. There is an exception here, and it's
Mm-hmm.
around Kubernetes. So for Kubernetes we actually have a um, collector distribution for Kubernetes that is
Mm-hmm.
a Helm chart and operators that you install, and is kind of pre-configured to give you Kubernetes monitoring.
Okay. Nice.
um, but
Speaking of my question from earlier, yeah.
yeah.
So the standardization part is like standardizing on how it's receiving information, and it's standardizing on how it's exporting that information. And the processor
Yeah.
part is for you to
Yeah,
fill in.
the standard is the standard cover the standards are really around those conventions of like this is how the data is formatted, this
Uh huh.
is how you communicate that data to other places.
Uh huh.
um and this is a good way to think about it is this, like the standard is how do we get to that ubiquity, the ubiquity part of the argument. Like we
Okay.
have to in our perfect hotel future, like
Uh huh.
there's no like you as a developer never have to go and like install hotel because it's just part of like, your language,
Yeah.
you know, like or it's a checkbox somewhere.
Uh huh.
And in a lot of cases I think we would even say like we don't necessarily, maybe this is something that like .NET does. Like in .NET, you actually don't use the OpenTelemetry API. You use the system.diagnostics API. And what they've done is they've bridged that into OpenTelemetry.
Nice.
So it's actually just part of like the common the standard lib almost, right? Like you just have tracing and you have metrics and all this stuff as part of your standard .NET library, and it works with OTel behind the scenes. And we think that's a super interesting pattern, right? We would love to see other languages and other like frameworks and app runtimes like embrace that and say like, yeah, we're just going to do OTel. And that's something that you can totally do while following the spec, right? Like the spec it doesn't say you have to use the OTel API. It just says you have to be compatible with the OTel API so that if someone else is using it, like, everything works together. And I think as the project matures, we're going to have better ways to kind of talk about that and discuss that and like make that provable. Because right now we're still very much in, get stuff shipped mode. Like this, we have our
We'll make it now. We'll talk about it later.
yeah, like we're still making. But I think once hopefully in the next year or two, when things get a little more settled and we have a lot more things that are kind of like 1.0 and are more stable, then we'll be able to really lean into developing that ecosystem out.
Here's another question about collectors.
Mm-hmm.
If you want to obfuscate PII and you want to, I don't know, change one signal to another, maybe at different points, or maybe at this, like, does it make sense to make one collector that does several things? Or is it better to separate them out into different? Can you tier the collectors?
You can tier them. You can do all in one. Like it's super flexible.
Okay.
There's definitely considerations. Here's one consideration. Do you want to put all of your signals through the same collector, or do you want to separate them out by signal? Some people, just put traces and metrics and logs and whatever in like one collector, or don't, but there's like arguments to do it the other way. Maybe, if you have like log processing or some sort of redaction process that can kind of be heavy, then you actually don't want to be you don't want all that to be going through the same place. You want to put your more lightweight telemetry, your metrics over here in a different pool of collectors, maybe, right?
Or I mean, couldn't you do like uh, logs, metrics, traces? These are collectors.
Yeah,
We'll
you
just do
you
all
can put them in separate collectors.
You put them in separate collectors to maybe filter them down to what you want, and then put them into another collector.
Yep.
That's going to then get it to all to one database.
Exactly, and
Something like that.
that is a very common pattern. Agent gateway model.
Agent gateway. Oh, that pleases me. Agents gateway. So this is like considered a gateway, and these are the agents.
Yeah, and there's a lot of there's actually some if you look at I think on the OTel website, there's like been some blogs about this, and we're actually trying to get a few of these common deployment patterns into our docs. But and also just shameless shout out, there's a chapter in Learning OpenTelemetry now available from O'Reilly Books that talks about this as well. So
nice, cool.
But yeah, there's a variety
Yeah.
of different deployment patterns, and you're going to use, and again, there's like trade-offs with all these, right? Like the more collectors you add, the more processing you do, then you obviously are adding latency before it's able to get to where it needs to go for alerting and analysis. There is unfortunately rarely there are a couple of like good starting points, but there is rarely just one right answer in every circumstance.
Ain't that life?
That is definitely OpenTelemetry is one of the more it depends sort of projects that exist, I
So,
think.
so the OpenTelemetry collector is a data pipeline Swiss Army knife that helps you do stuff with the data that you collect.
Yep.
And so some examples: obfuscate, PII, dedupe, transform from one signal to another, drop, filter. And you do that by writing your own processors.
Hmm.
And so these can be tiered, and they seem to be commonly tiered. And there's a couple of things to consider. So the examples of considerations would be like, do you want to put all your signals into one collector, or do you want to separate them? And then also to consider that more collectors adds processing cost and latency.
Yeah. And oh, and the other thing I will say about collectors is it also, like, the other thing you want to consider is how your software is deployed, right? Like, are you
Okay.
deploying onto VMs? Are you deploying in containers? Are you doing serverless? Um, because that can also sort of influence like your collector strategy.
Will you give an example?
Yeah, so like if you're like, let's say you're running on VMs, then
Mm-hmm.
a pretty common pattern there is to actually just have like one collector as a system daemon that is
Okay.
collecting like both
Uh,
CPU, OS level stats and also telemetry and also doing logging and stuff.
mm-hmm.
But maybe if you're doing something like a Lambda
Mm-hmm.
or serverless, then you actually want to use like a combination of these where you maybe have, because your scale can be so elastic, or you have such an elastic scale when you're talking about something like a pod or a serverless workload, then maybe you actually want to put the collector closer to the job and either as like a sidecar or as a part of a Lambda layer, so that,
Mm-hmm.
like, especially in the case of Lambda, if you're using a layer or extension with the collector and to do that processing and not doing it in the executable code of the function, then that can kind of exist longer than the function call does and
Mm.
helps prevent dropping data, right?
Okay.
Same thing with pods, where if you have stuff that's kind of like longer lived, maybe sidecar is not a good example, not great, and you want to use like a daemon set or a stateful
Uh-huh.
set. Again, there are good starting points, and we try to document a lot of those, but everyone's actual answer is going to depend on a ton of different factors. This is also why it's usually, good to do some reading or like talk to people in the community, right? Like, we have a really vibrant community. We're on the CNCF Slack. We're, in Stack Overflow. We check Stack Overflow a lot. We check,
Okay.
our GitHub issues, and love people coming in with questions, and it helps all of us learn.
If I was implementing this and had questions, is the CNCF Slack workspace the best place to ask them?
It
Or
depends on the question. I
uh-huh.
think there are, depending on where exactly the question, what exactly the question is. So if it's
Mm-hmm.
like with the collector or something, there's, I believe, GitHub discussions for a lot of our repos, or you can create an issue, um, or you can come in and ask in Slack. But we are kind of we are an international project, so people might not be on Slack when you are. Um,
Yes, yes,
I
yes.
think probably the best way, I tend to push people towards like things like Stack Overflow or GitHub discussions as a first cut,
Okay.
just because like
Those answers
that's
are
where
more
it,
findable for the next person.
yeah, right, like it's you're pushing you're passing the knowledge on forward. Um,
Yeah.
the other thing I would say is we have a lot of open meetings. So if you look at
Mm-hmm.
our website, there's a public calendar on there, and you can actually just join like a SIG meeting, and you can talk to the maintainers and ask questions there. Like, I've never heard of anyone getting run out. So
Yeah, awesome. Ravi's here. Hi, Ravi. Thanks for coming, friend. It's glad to see you. Um, so I think I got to ask all of my questions in terms of strengthening my mental model, and you've helped tremendously. Thank you so very much.
Well, thank you for
Um,
having me.
oh
Thank you
yeah, and I
for.
don't know that it has to be the ends. It can be, but we still have some room. If you had some things you wanted to talk about in terms of the open telemetry vision, perhaps, or
Hmm. Well, let me talk a little bit about like what's coming next in OpenTelemetry, because I think that
yeah.
we've talked a lot about. I know I said earlier that there's no, we don't believe in three pillars, um,
Mm-hmm.
and then all I've talked about since is traces, metrics, and logs. So one thing that we're working on right now, there's two things we're working on right now, and one of them is um, profiling, and the other is events. Events with a capital E, which is not confusing at all. So the name might still change. But
Did you say instead of three pillars, it's a braided data
yeah,
stream?
it's a braid of data. It's a
Braided data.
braided data.
Braided
Braided
data.
data. Say that three
Braided
times
data.
fast.
Okay, what's coming next? So there are two things you mentioned: profiling
Profiling and
and
capital E
events.
events.
Yeah.
So let's talk about them in order. Um, Profiling, I think people are, I feel like, usually pretty familiar with it, but just to level set, like the idea of the profiling, specifically continuous profiling, is that you have something that is running alongside your code that is able to continuously look at the stack trace of your software, and then when there's an exception, or whenever, you can just say like, hey, dump a profile of what's in memory, and see like a flame graph of like, hey, this is my call stack, this is what objects are allocated on the heap or stack, um, this is how much memory is being used for allocations, or whatever, right? And this is a continuous sort of process that is just kind of running there in the background, and then when I need that really 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 low level view, I can get it.
So it's a continuous process that's running alongside your application.
Yeah, that is giving you like super low level insights into what's happening in your code.
Um, oh, hold on. Uh, I have a question, but I
Okay,
want to finish writing. I have to dump my brain first. I have to buffer.
you're good. You're good.
Uh, that provides low-level insights. Is this eBPF is my question. It seems like it needs to be eBPF.
Um, there are both eBPF and non-eBPF ways to do this,
Okay. Okay. That's
but
all. It's a quick. It
yeah,
was
there are
connected.
many different techniques. One of which, or eBPF is one way to do this. eBPF being extended Berkeley packet filters, which is a way to do fun userland kernel and stuff that I don't
Good to
fully
hear.
understand, but people are very excited about it. So,
Yeah.
without dwelling too much on the specifics,
Uh-huh.
um, we are adopting profiling as a top level sort of part of the data model. So that
Mm-hmm.
means that profiles from OpenTelemetry would get the same benefits as anything else, right? So they would get
Oh.
transaction context, they would get resources and metadata and semconv and all that sort of stuff. So
Mm-hmm.
that leads to there's some really cool things that can happen there with that same sort of, you know, that same sort of loop of like, oh, I mean, really, it actually is like really, really cool stuff, because you can imagine like, oh, I see this metric says that, it's like this histogram shows errors over here in these things. And then I was passively recording profiles. So I'm going to dump the profiles related to that transaction to something as part of an
Mm-hmm.
alert. And right, like you imagine cool stuff. Imagine cool
Mm-hmm.
stuff. But they're definitely like on the same level as these other things, right?
Uh-huh.
Um, The second big next thing is this idea of events. And again, name not final. But the idea I've talked about, I've used the word logs quite frequently in this discussion,
Uh-huh.
and logging is such like a super interesting topic because everyone has a lot of opinions about it, and OpenTelemetry generally takes the position that like all of your telemetry data should be structured, have a semantic meaning behind it.
Mm-hmm.
Right now, what we are trying to kind of align on is what to call our API for emitting that kind of instantaneous structured data. And the word we've settled on so far is event. Um,
Mm-hmm.
Logically distinct from a generic sort of event that occurs that we talked about earlier, but a capital E event is
Uh-huh.
something that happened that has like a structure and a format to it. So you could think of this like a structured
Mm-hmm.
log, but you could also think of this as a user event or a cloud event or a CI event or
Mm-hmm.
um and this is super important for several reasons. One, because this is something that is really important on uh, client observability, right? Front end web
Mm-hmm.
clients, mobile apps, whatever, they need this kind of thing. Um, but also like other stuff, right? Like user analytics would need something like that. Needs something like this, or things from a CI system and feature flags kind of play in this space too. So we are very close to having this stuff nailed down in the spec. If either of these sounds super interesting to you, then you should definitely come check out the our our GitHub and look at the spec and look at the discussions happening there because it's very active still.
So, so are you saying so like profiles are going to, so they'll be if these catch on, it'll
Yeah.
be like logs, metrics, traces, profiles, and events. Like these might become as important as the what's
I
traditionally referred to as the three signals.
Yeah, so I'm the way I what I'm trying to get over is there just being four things. So profiles, metrics, events, and spans.
Oh,
PEMs. Or you can also
profiles, metrics, events, and spans.
spans. Or the other way you could say is SEMP, spans, events, metrics, profiles, or SIMP.
I'm running out of room on the
I
board.
know, but
But this is
don't
like a
write that one
goal.
down. I that that
Oh,
that I'm
this is
that's a
like a that's okay.
yeah. Don't put that one down yet because it's the yeah. Like without I don't want to overwhelm. Like
It's
we've been
fascinating
talking over an
though.
hour. Yeah, we've been talking for a long
Yeah.
time, and it is very fascinating. But just like the that statement is probably going to like get people mad at me if they watch this video. No, it's just like there's a lot there, right? Like logging as a concept is so ingrained in tech. Like
Yeah.
saying something like, "Well, you shouldn't do logs," like even if you have a really good reason
Or
for it,
uh-huh.
but maybe
Or
you
oh,
shouldn't.
or
Like,
maybe a log is just something that sits alongside your user event or your cloud event or
right,
like
or yeah, the way I
it's
described it is like
enriched.
all events are logs, but not all logs are events.
Okay.
So
Okay.
it's really just trying to. I think the big conceptual difference is that OTel sees like the biggest problem with logs as a concept is that there is no guarantee. The only thing you're guaranteed in a log is that it has I mean really nothing, right? Like you can console.log whatever you want. There's not even guaranteed to be a timestamp.
Yeah. Or a
Um
truth. It could be a lie.
yeah. Like Whereas everything else in OpenTelemetry is really defined by the fact that there's a structure and it's important, and that structure is important. So you have, metrics, their structure is important. Spans, their structure is important. Profiles, same thing. It would be weird for us to have this other thing over here where it's kind of like, anything goes. So
Yeah.
yeah,
Logs are the black sheep of the signals that are no signals.
yeah, they're the
Um,
signalless signal,
is
but people love them.
OpenTelemetry.io the right address?
It is
Okay.
OpenTelemetry.io.
So if you feel good about it, if you feel like it's time to wrap it up, the way we're going to do this is I'm going to go back over. I'm going to recap with you everything
Okay,
you taught me to make sure I have a good understanding. Does that sound all right?
that sounds great.
And those of y'all in chat, if you feel like asking questions, now's the time. So we started with a history lesson. So I learned about projects called Open Tracing and Open Census, which I didn't know before. About what year was this?
20, 20, like 2016, 2017, 2018 time frame.
I'll put 2017 with a tilde.
Yeah,
It
that
means
sounds
ish.
right to me.
Okay, around
And
2017-ish.
yeah,
I'm kind of surprised to find out how
the,
recent these things are sometimes.
yeah, the pandemic also completely ruined my sense of linear time. So, um,
Yeah, totally. Um, so open tracing was created to help making as a standardization to help make distributed tracing more popular, and at the same time, open census was created around creating a standardization around tracing and a different standardization around tracing and metrics. I think in general in tech, when a standardization is needed, it's common for it to be invented a few times over and see which one sticks.
yeah,
So, but all of it, everyone can agree that telemetry data should be vendor agnostic and it should be a built-in part of observability tooling and maybe just observability in general.
it
So,
should be a built-in part of software in general. Yeah.
ah, bold.
Eh.
Yes. Open tracing and open census came together and made open telemetry.
Mhm.
And then it's not an important part of the story, but I was stuck on how open metrics and Prometheus fits in. But I think it's probably speaks to a larger issue of like, here's a new standardization that's picking up some steam, but in order for it to grow, other tools that already exist have to adopt it. And so Prometheus is as ubiquitous in the metric space, but even it's true of commercial products. It's true of all the different tools who.
Yeah.
So Prometheus and OpenTelemetry seem to have each come together to join up. So Prometheus in the next release will start using OTel SDKs, which I have a better understanding of what that means now.
Yeah.
But OTel understands Prometheus metrics
Hmm.
as they are, and Prometheus metrics and OTel metrics work well together. So it's been a joining of forces there. But anyway, OpenTelemetry is a model for how to translate system events into useful data for observability. So it's a comprehensive and thorough foundation for observability. And so specifically, OTel is three things. It's a standard, it's a specification, and it's software. So that's the collector APIs and SDKs, which we'll talk to about shortly. But really, it's the underlying assumption, or not assumption, fact, is that there's a vast and unknowable number of events in a modern system. So where do you even begin? And I think the beginning is the standardization about how you even talk about things. And then once you have that, then you can make standardization about how to do lower level things. And then once you have that, you can make maybe some standardization about how to do some more complex things.
Hmm.
So, and another thing that adds complexity to all of this, like all the different signals we talked about, of course, logs, metrics, traces, and maybe some new ones. And then also we talked about observability at an application level, in between applications, at a system level. And then to add more complexity, we also talked about telemetry data being semantic. It means different things to different users, and how can we give it the context so that the different users who want to see the different contexts of possible contexts of a single data point can do that.
One thing I want to add there, because I don't know if it came up, but like when we think about the users of telemetry data, we also need to think about like the systems that are processing it, right? Like the
Uh-huh.
not just human beings, but we need to be able to tell the consumers of that telemetry data, like, yo, this is how you interpret this, or this is what this means.
Uh-huh.
And I think that the semantic or the semantic and structural sort of nature of this data benefits both of those groups, right? Not just,
Entities, human
yeah,
and
both of those
machine
entities.
users
Yeah,
both. Yeah.
yeah, humans and machines. We love them. We love humans. We love machines.
It's true. So what makes telemetry data useful? When we say it's useful data for observability, there are two main aspects that will make it useful. One is that it's highly correlated with other data in the system.
Hmm.
And then two is this standardization, that ubiquitous standardization that we're talking about to be important to build the higher and higher level things. So first we have we didn't talk too much about the actual like format style standardizations, but presumably they're there.
Yeah,
Um,
it's not super
Probably not.
interesting.
And then the period goes after the yeah. But then the lowest level then is a OTel API. So this is happening each at the language level. Each implementation has an OTel API. Each language, has an OTel API implementation.
Hmm.
And it's basically how a developer is able to translate code level events into a telemetry signal. So it's a standardization around that.
Hmm.
And so now with that data, we can use the OTel SDK. So now we're on our third level of what we're able to do based on since we have our standardizations. So this OTel SDK, it can listen to signals from the OTel API, and it can do some cool things. And for one thing, it helps define the context for your system, which is at the core of making telemetry data useful. So it knows things like what was happening at the same time as a certain piece of data, or what is this piece of data part of a larger transaction. And what's cool is this context is added automatically, and more context is added that you called OTel semantic specification. So like metadata context. Examples you gave would be feature flags or resource usage, which load balancer a piece of a request went through, or HTTP status code. But these this metadata can be is also standardized, and given it helps give context. And yeah, so the OTel semantic specifications are standardized metadata about things that happen.
Yeah,
So now we
semantic
understand
conventions. Sorry,
semantic specific convention.
semantic conventions.
I may have written it down wrong. You
You,
don't need.
I
Uh,
probably accidentally a word somewhere, but yeah, semantic conventions.
cool.
I just don't want people to get confused looking for it, because like they're in GitHub and everything is semantic conventions. So
I'll tell semantic conventions. So now we've collected our data, and now we have a lot of context with the data, how it relates to each other and how it relates to other things in the system.
mm-hmm.
And then what do you do with the data you collect? And that's where the third piece of OTel comes in, which is the OTel collector. So you called it a data pipeline Swiss Army knife.
Mm-hmm.
But basically, it helps you do stuff with the data you collect. And so the amount of things you can do is wildly, wildly vast. We gave some few examples just to give it some color. The examples we used were obfuscates, PII, dedupe or deduplicate data. You could transform from one signal to another, one signal to another. You could drop data, you could filter data. But either way, you do this way, writing your own processors.
Mm-hmm.
And the collectors, they can be tiered. We talked about an example where maybe each signal has its own collector, and then you use that collector for the signal to drop part of it, to filter it, so there's less, and
Hmm.
then you send that all to another collector that then aggregates those signals together before sending it on to a storage place. It is a common use case, you said. That I didn't really think I made it up, but I did come
No,
up with
no. I
it.
mean, it's
um, so you said when you're using an OTel collector, when you're designing how you want your OTel system to work, there are some considerations. Do you want to put all your signals into one collector, or do you want to keep them separate? Like, how are they going to be queried in the end, really? There's a warning that more collectors will add processing time and latency between the collectors if you tier them. How your software is deployed will probably very much affect your collector and your observability strategy, VMs versus containers versus serverless. And he said overall, it's all a balance between having your data be available, being able to get access to it quickly, and your data integrity. So you will float between. I think you said use a puck. Your puck will
yeah,
go
it's
between
like
these
a
three pillars. Yeah,
yeah,
I'm thinking of a Ouija board.
kind
Uh,
of.
as you figure it out, what's best for you and your use cases. You said we, I assume by we you mean
Hotel,
those
yeah.
of you in the observability in the hotel. You don't believe in three pillars. You believe in a braided data. And then we talked about what's coming next, which is super duper exciting. So we talked about continuous profiling. So there's a continuous process that's running alongside an app that's providing low level insights into what that app is doing. And the data that comes from this will be treated as importantly as logs, metrics, and traces in terms of OpenTelemetry,
Hmm.
standardization, and such. And then we talked about events. So something that's happened out that's has a structured output. So this could be a log, that would be a most familiar type of event, but also it could be a user event, like a user action or a cloud event or many other things. But kind of expanding on what a log could be and then giving it structure. Um, and that's all. If you want to learn more, go to opentelemetry.io. Is there anything you would
I
like to add?
I think we got it. That's like the most comprehensive overview of hotel I think I've ever given. But
It's been a joy. I have, this is um, the second episode I've done on OTel. I did one, I think maybe 2 years ago, almost 2 years ago.
hmm
And I didn't, the other one was perfect for what I understood about observability at the time. And this is a perfect like V2 kind of dig into what each of these things means.
it's
So,
definitely come a long way in 2 years, and
yeah.
I it's such an exciting project. Like, and it's been super. What's been really cool about it is kind of seeing this organic adoption from not just like vendors and people building observability tools, but like just today. Like I was in Slack and there was a guy that came in. It's like, hey, I'm working on this middleware framework and I'm trying to understand how to natively add OTel support to it. And it's just
Uh-huh.
like, that's exactly what we want you to do. Yes, thank you. You get it. And that's
Uh-huh.
really cool.
That's awesome. It must feel really satisfying in your shoes because you've been there since the beginning, more or less, haven't you? Weren't you
Yeah,
at the
and I
beginning?
mean,
Yeah.
I don't want to take like a ton of credit for it.
Oh,
I am
yeah.
a small part of this. There have been people, um, there's been a I would say like 20, 30 people that have kind of been there since the jump. It's
Mm-hmm.
definitely 100% like a team effort. This is
Yeah.
no one person's baby, but it's been really cool. It's also been really super cool because so many of the people working on this are competitive. Like we don't all work for the same company, right? Like we
Uh-huh.
are nominally competing with each other, but we've had years and years of great collaboration. So I think it's a really cool example of you know what you can do in sort of like the commercial open source space, like that doesn't require single corporate governance and da 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 da. Da.
That's awesome. That's so cool. Well, this has been an absolute joy. Thank you, Austin, for sharing your time.
Thank you for
I
having
usually,
me.
yeah. Let's see if I can. You hear music right now?
I do not hear music right now. No. Oh, now I do.
I don't hear it. It must be. I usually dance at the end. Oh, nice. But I can't hear it. Bye, everyone. Thank you so much for joining. Thanks to y'all in the chat. Thanks to folks who watched the recording. Thank you, Austin. Goodbye.
Bye.